Absolute values today. Now we're going to throw inequalities with it as well. The same principles to graphing a regular absolute value will be applied here with our absolute value inequality. But obviously at the end, we're going to be talking about whether it's dotted or solid and how we shade. All right. Now off to the side here in the red, I have the formulas that we're mainly going to be using to help us graph, and then we're going to be applying them here. Right off the bat, I noticed this is not in vertex form, okay? Do not try to get the vertex unless it's in vertex form, all right? They need to share that name. Get y all alone. Basic Algebra 1 principles. We're going to move the 6. Now keep in mind, when I subtract this 6, it cannot combine with an absolute value number. So it goes on the back side, the caboose. So we're left with negative 2y less than 4 times the absolute value of x plus 2 minus 6. Still not done. I need to get the y alone. So, basic algebra principles. To undo multiplying by negative 2, we divide by negative 2. Now, I'm going to divide each term here by negative 2. I know there's a lot of numbers, but because it's all being multiplied, it represents one term, so I can divide it all by negative 2. Here we cancel, left with y. Oh, that sign flips, baby. We get the greater than now because we have flipped. The 2 and the negative, the 4 and the negative 2, we can reduce and make it negative 2 times the absolute value of x plus 2. On the back we get plus 3. Okay? Now if you'll look, it is very similar, pretty much identical to the vertex form. Just for purposes before we move forward, my a value is negative 2. My h, we've been struggling with this. Listen, my h value is negative 2. If you'll notice, the original format, we subtract our h value. So, but this is addition. Yeah, how does addition become the actual result of subtraction? When you subtract a negative. That's what's really going on here. So my h value is negative 2, and the k value is 3. Again, the little phrase we use to help us remind us, h is opposite, k is okay. Meaning the h value will always be the opposite of what you see, and the k values, it's all right the way it is. So, using this, I'm going to find my vertex, which is the h comma k value. h, k. Just so we're clear, this negative 2 is coming from that value, not that value. Don't get that twisted. Now, start your actual chart. Makes life pretty easy. I'm going to go up 1 from the x value and then up 2. Well, I'm pretty good at counting. Plus 1, we get negative 1 and then a 0. These values are underneath the x column. So that means all I do is I plug them in to my x value. So we're going to do some mental math right now. Stay with me. Ready? Go. Negative 1 plus 2 is 1. Absolute value of 1, 1, times negative 2, negative 2, plus 3, 1. Everybody follow that okay? Same thing again. Mental math, get it. 0 plus 2, 2. Absolute value of 2, 2, times negative 2. Negative 4 plus 3, negative 1. Okay. I have 3 points. Let's start graphing it. So I go to where my vertex will be. Now again, the vertex really acts as the door hinge. All of our points are just going to be revolving around that. We're going to be mirroring them in a little bit. Negative 2, 3, right there. Negative 1, 1. And 0, negative 1. Now, it is so important you know where your vertex is. That's what you mirror around, okay? That was my first point, that was my vertex. I'm gonna put a little dotted line so I see what to actually mirror things around. This point here is 1 to the right, so I go 1 to the left. Makes life easy. 2 to the right, what's up? 2 to the left. Okay, now, that's all the skills we needed to graph an absolute value. But now we're jumping up and we're gonna be doing an inequality. Now, if you remember, if you are less than or if you're greater than, you're going to be doing a dotted line. If it was equal to, then it'd be a solid line. My whole thing is if you see the line, be the line. I don't see a line, so it's going to be dotted. Dotted line skills like crazy. All right, now we have to shade. We have to understand what region contains potential answers. So what I'm going to do is test a point. Now we love picking easy points, points that are not difficult to test. I want you to be careful. You can never pick a point on the line. It's not going to help you. I like to pick a point that's easy but decent away from the line. So I'm going to pick a point over here. I'm going to pick, let's go 1, 1. This is my tester point. It's clearly on the outside of the absolute value. So it's the point 1, 1. I'm going to use this point to plug into my inequality to see if it creates a true statement. If it creates a true statement, that means its region is true, and that's where we shade. If it is false, we shade the opposite, which would be the inside. So let's check it out. Testing 1, 1. Testing 1, 1, right? Whatever. So we plug in the y value, we get 1. Greater than -2 times x is now replaced by 1 plus 2, absolute value, plus 3. All right, mental math, let's get it. 1 plus 2 is 3. Absolute value of 3 is 3. Times -2 is -6. Plus 3 is -3. I've evaluated, I've plotted my points in here. This statement reads, 1 is greater than -3. Well, I'm not a genius, but I know that 1 is bigger than -3. So this point just produced a true statement, which means I shade the outside. That's graphing absolute values. Get it in vertex form. Marker fell, who cares? Get it in vertex form. Find the vertex. Get your table of points. Plot them. Mirror them to the other side. Dotted or solid. And then test a point. Hope it helps.